All right, let's keep it going with 5.4. We're going to graph and model with sine and cos. Graphing is a type of modeling. Coming up with an equation is a type of modeling. It's a way to represent a mathematical statement or an equation. We can do it graphically, we can do it equationally, whatever. So I'm going to start us off by sketching the graph of g at x. We know from 5.3 kind of what to do, but I'm going to give you some steps that are kind of no fails on how to graph any type of trig with transformations. Step 1, you need to know your max and your min. You want to draw your max, your min, and your middle dotted line. The middle value is just the c value. So the c value is where I usually start, positive 1. If there's nothing there, it's a 0. So at positive 1, I'm going to draw a dotted line right across. And once I have my C value, it's much easier to understand max and min with the amplitude from the center than it is with like a formula. Max plus min divided by 2, max minus min. Oh, I made a mistake. I picked the wrong formula. Don't use a formula. When you have the max line or the middle line, this bounces 4 up. So 1 plus 4, 5. That's your max. From the middle line, I have to bounce 4 down. So negative 3. See how easy that is? Just logic. Never mind formulas. Now, all my y components are done. I've dealt with the 4, I've dealt with the 1. Now I have to just deal with the k value. And I do that with my scale. So I'm going to use this k value, which is 3, and I'm going to say, well, the period's got to be 360 divided by 3. I always do this. I need to know the period before I scale this. This is going to be p is 120. Period is 120 degrees. Therefore, my scale is a quarter of that. 120 over 4. It's always over 4. 60, 30. This means if I scale by 30, it'll be really easy to graph this. So I'm going to go here. I'm going to go 30, 60, 90, 120, 150, 180. Am I going to make it? Doesn't look like I might make it. 210, doesn't say where to graph it, so 240, 270, 300. I'm gonna graph this from 0 to 300, whatever. Okay, so I don't graph this using transformations from the sine function, shift it, vertically stretch, or horizontal compression, or vertical translation. I just do it this way because it's so much easier. If you know how to graph sine at x, you know how to graph any variation of sine at x with these steps. Step 1, deal with all the y values, done. And then this, your scale. Once you know your scale, once your scale is done, honestly, you're done. There's nothing else you really need to think about. All you need to think about is, where is this function starting? Well, there's no phase shift, x minus d, there's no phase shift. So I'm gonna start on the y-axis. Sine is gonna start on the y-axis. And I know that sine starts in the middle, right? Sine starts in the middle, cos starts on top, negative cos starts at the bottom, negative sine starts in the middle, but starts going down. Now, once I have my first point, if I've scaled this properly, every scale, I move to the max, I go to the middle, I move to the minimum, I move to the middle, I move to the max, I move to the middle, the minimum, the middle, the max, and I'm done. Connect the dots, and I've graphed a beautiful model of this equation right there. It feels like I did nothing. I just made right decisions. I drew dotted lines so I know quickly where to draw dots. I figured out what to scale it with, which is always this. You could run into problems with this if your phase shift is like 45, but I'll explain that when we get there. But that's it. And then it's just knowing where you start. What's your phase shift? So the next problem I'm going to show with a phase shift, just to show you that just start at that phase shift and do the same thing, and you account for the phase shift actually. Okay, so for this next question, I'm not graphing anything, but I'm coming up with an equation based on a scenario. So you're gonna have word problems in 5.5 and 5.6, and you're gonna have to come up with an equation based on a scenario, which is a word problem. So without anything they have to think about, this is a very, very bare bones scenario. I have to create an equation of a sinusoidal function with an amplitude of 3. That's really easy. It just told me what the amplitude is right here. Right, so A is 3. A period of 180. Well, if I know the period, I can find out the k value. And a maximum at 0.5. That's going to be the trick right there to continue this. But those two first pieces are really, really easy. So let's make our equation already. Y equals, I know it's going to be a 3 in the front. 3. Let's go, I'm not going to use sine, and I'm going to explain why in a sec. Okay, I got to come up with a k value, right? I have to do k, and then x minus d, if it exists, and then plus k. Okay, let's do the k value. Just like k is 360 over p, or p is 360 over k rather, that's what we use more often, they're interchangeable, right? I can multiply by k and divide by p. So I can use this equation if I have the period and I need to find the equation. So k is 360 over 180, k is 2, and I'm done the k value. Just that easy. Okay, so this max, because there's nothing else I have to do. Maximum value at 0.5. So this function has a maximum value at 0.5 somewhere. It doesn't really matter what this means. I'm using cos because I saw that 0. If I'm starting on the y-axis with a max or a min, I always use cos because I don't have to do a phase shift if I do that. So cos starts with a max. If I don't use a phase shift plus 0, this works because cos starts here and it's going to do this, whatever it does, right? But as long as the max is at 0, if this said like 3, then it's just going to shift over here, right? And then I can start over there and do the phase shift to 3. But I always look for where cos starts, where sine starts. You're going to see that way more obviously in tables when we come up with a table in 5.5. Okay, now this c value, bit of a trick to understand it from here. If my amplitude is 3 and my max is 5, I know that those 3 lines that I always draw, right, in my graph, my max, my min, and my c. Well, if I know that this is 3, the amplitude, and the maximum value is 5, if I just subtract the 3, I know my c value is 2, and I'm done my c value. Okay, so take a look at that. Knowing what the max is and the amplitude, I can understand this triple dotted line in the same manner. I know the max is 5, I know the amplitude's 3, so go down 3, you have your middle. Go down another 3, you have your minimum, -1. Okay, so this is wrong. This should go down to -1, right? I didn't know that at the time. Whatever, it doesn't matter. But that's it. I know the amplitude, I know this from the equation, and then these were a little tricky because I have to kind of use some knowledge there to figure that one out. But I mean, draw a little crappy diagram, use this. This is like the best thing ever invented for trig. These 3 lines are lifesavers. Even when you do word problems, you're going to understand max and min, and it's going to be awesome. Okay, we'll do one more question. Okay, so this one, we have to model this model. We have to model it using an equation. So we have to come up with 2 equations for this following graph. It's already here. I may think I know what certain numbers are. Don't assume certain things. Some visual tricks, especially when the scale is small, can mislead you. So please be careful and don't rush. Now, I have to come up with 2 equations. The one you want to start with is probably the one that looks like the function should be starting on the y-axis. So I don't have to deal with a phase shift. But that's not true. I don't have to do that. I can come up with a cosine function shifted over here. I can come up with a negative cosine function shifted over here. I can come up with another cosine function shifted up here. When I say shifted up here, I mean shifted this much over, 120 and 30, 150. Right? This is 30 shift. Because cos starts at the max. Negative cos starts at the bottom. Sine starts at the middle and goes up. Now, the visual trick sometimes could be you think that the x-axis is actually the middle of the function, but it's not. Don't make that mistake. Just find the midpoint between the max and the min. If you know that the max is 3 and the min is -5, if you add them and divide by 2, you'll get your dotted line right in the middle. It's really easy to do it that way. Okay, especially word problems. I'm going to probably talk about the max and the min, so you can find your c value just using those 2 numbers. Find the midpoint. Done. Now the amplitude, you can do half of the distance between this, but it's really easy. Just look, 4. That's it. So I know that the amplitude is going to be half of the distance right there. I know the c value is going to be -1, and I'm done all the y values. So my equation so far is going to be y equals 4 sine, don't know this yet, don't know my shift yet, but I know my c value is -1. Okay, so the y values are the easiest things to do. So get them over with. Done. Now, let's talk about the k value, or all the x values in the brackets here. The k value is really easy because we know that k is 360 over p. So I need p. Well, if you know anything from 5.1, you can find out how far away a function or a pattern starts repeating itself in any way you want. I can go from max to max, and that's 1 period. I can go from starting point to the next time the period repeats, so that's 120. I like doing it that way because it's from the starting point, unless that option isn't available to me. But I'm always going to do that because I always want to subtract a number and 0. This is 0. So 120 is the period. So k is 3. Done. Now let me just show you if you did it over here. This is 30, right? That's 30 in the x. This is 150. The distance between them is 120. So you get it any way you want. Use the minimums, the distance here, it's all 120. So the period's 120, the k value is 3. Now, this shift over here. I wrote sine because I'm starting to write a sine function because I don't want to use the shift over here. So see how sine starts over here? It's in the middle around the c value and goes up. That's where sine starts. There's no shift. This is the final answer for an equation. Y equals 4 sine of 3x minus 1. You don't have to put a plus 0 over here. It's kind of ridiculous. So my first equation is y equals 4 sine 3x minus 1. Let's come up with some other ones. I'm going to pick a random point right here. Okay, and where do you start when you come up with an equation? I always start closest to the y-axis. 0 would be great, but a small number that's close to here, so my eyes don't really have to wander away from this information. A lot of information is around the y-axis, so stay there. Okay, so this shift is 150, right? It's 150 to the right. That's where cosine starts. So I can write a cos function over there. I don't know why I'm writing it there. Y equals 4 cos of 3 x minus 150 minus 1. Sorry for the space. So nothing changed except this and this. This is 150 to the right. Let's do another one. Look how easy this becomes once you get it. Let's do this one right here. This is where negative cos starts because it's at the minimum. So y equals negative 4 cos of 3x. Sorry, there's extra brackets here for no reason. You can put square brackets here. That's what I like doing. What's my phase shift here? Well, if I'm starting at this point in particular, this is 30 plus 60 is 90. This is 90 in the x. 90 to the right. That's it. There's nothing else to it. Oh, I'll come up with another sine function. No problem. All of these points are when sines start. This is sine, this is negative sine, because it goes down. This is sine, this is negative sine. So pick somewhere where sine starts. I don't know. Let's go negative sine, the 60. Y equals negative 4 sine, open brackets. The k value can never change. It's just that shift that changes. I want to shift 60 now to the right. This, these are all the same. Which one would I prefer? This one, because there is no phase shift and it's less writing. So I always look around the y-axis, try over there. But questions in your homework or on a test are never going to give you the option to start over there because it wants to see what else you got. So if it looks like sine is the easiest way to go, the question is probably going to say, come up with a cosine function to model this. Okay? And that's not a problem. If you know sine is starting here, I will explain it when we do word problems, but sine and cos differ by 1/4 of the period. Right? Sine starts there, cos is there. That's 1/4 of the period, scale factor, period divided by 4. I hope this is not too confusing for something so easy. That's it, done.